All right, guys, today we are going to learn how to solve simple series and simple parallel circuits. So first off, you have to know how to identify when you have something wired in series. The easiest way to identify it is look and see if it splits at any point. So in other words, a series circuit does not split into separate branches. So if you look at your circuit and you see that everything's on the same piece of wire, that means it's wired in series. Okay. In a series circuit, current is the same on every device that's in that circuit. So if you have 3 resistors, every resistor is getting the same current. If you have 2 resistors, every resistor is getting the same current. Okay. But the voltage on each device will vary depending on the resistance that resistor or whatever appliance has. Okay. The bad part about a series circuit, they're very easy to wire, but the bad part about them is that if you remove one thing in the circuit, it opens up your circuit. You don't have a closed loop anymore, and that shuts off the circuit, and it won't operate. Okay? So we're starting off by giving a simple series circuit. How do I know this is series? Because I start on the positive terminal of my battery and follow the wire, and I have a resistor here. I continue through the wire, I have a resistor here, continue along the wire, I have a resistor here, and I get back to the battery. At no time did it leave that loop and start off a different branch. So that tells me that these resistors are wired in series to that battery, okay? So to solve it, first thing I have to do to solve it is I have to find the total, or what they often call equivalent resistance. For a series circuit, you find that by adding your resistors. In other words, R1 plus R2 plus R3 will give you the total resistance. These are numbered a little weird, and I didn't do that. I got that image off the internet. But just say this is 1, this is 2, and this one is 3. Okay? So we have 20 ohms plus 19 ohms plus 20 ohms. When you add these 3 together, that gives you 59 ohms. So that is your total resistance in the circuit. 59 ohms. Now, the reason I do this in a step-by-step manner is because what you figure out in this step, you're going to use in the next step. It's going to help you solve the problem. So for my next step, it's asking me to use Ohm's law and find the current. Well, remember that Ohm's law is V equals IR, okay, where you have the voltage from the battery, your current, which is what we're looking for, and your resistance. The resistance we're going to use is this resistance we found in step 1. So it's your total resistance that we want. So I'm going to take 10 volts equals I times 59 ohms. And so to solve that, I take 10 and divide it by 59. And that gives me 0.17 amps. It's rounded. It's like 0.16949, but I rounded it to 17. All right, and so that is my current that's going around the entire loop. That means each resistor is getting 0.17 amps of resistance. Okay, now this we're going to use in the next step. Our next step is to take the current that we found and find the voltage on each resistor. So in other words, for the first resistor, I'm going to take the current and I'm going to multiply by the first resistance. For the second resistor, I'm going to take the current and I'm going to multiply by the second resistor. And for the third resistor, I'm going to take the current and I'm going to multiply by the third resistor. So my current is 0.17. My resistance is 20 ohms for the first one. So 0.17 times 20 is 3.4 volts. 3.4 volts. Okay? My second resistor was 19 ohms. So I'm going to take 0.17, multiply it times 19, and I get 3.23 volts. And then my third resistor is 20 again. So 0.17 times 20 gives me 3.4 volts again. Now at this point you can add them and it should equal the battery. That's a check on Kirchhoff's rules. Kirchhoff's rules, because of conservation of charge, you must have the same electric potential added that was used throughout the battery has to equal your battery. Okay? So if you add 3.4 plus 3.23 plus 3.4, you get 10.03 volts, which is close. It's because it's rounded, it's going to give you a little bit of variation, but that's pretty much 10. Okay? Now, I asked you a couple of questions off of the circuit. These are extra questions. They don't have to be asked, but I'm asking just to show you different ways that this can be applied. How much power did the entire circuit use? So if I want power, I can take voltage from the battery and multiply it times current in the circuit, and that'll give me the power that the circuit used. So voltage was 10, the current was 0.17, so the power is 1.7 watts. So you used this circuit used 1.7 watts to operate. Okay? Now I asked how much power was used by the 19 ohm resistor. So only the 19 ohm resistor, not the entire circuit. Okay? So the easiest way to do that, I don't want to use voltage times current unless I use the voltage that I found up here, the 3.23, because that's how much voltage is on the 19 ohm resistor. But an easier way to do that when they ask about a specific resistor is to use the other formula, the I squared R. Because I have the current that's going through the resistor, 0.17, and I square it, and then I multiply times that resistor itself, the 19. So 0.17 squared times 19 gives me 0.55 watts. And that's it. Okay, so that's everything I asked you to solve for this particular circuit, the series circuit. But solving the circuit itself, in other words, finding the current and finding how much voltage each resistor is using, that's always the same steps. These questions are extra. Okay? All right, so now let's go on to the parallel circuit. The parallel circuit's a little bit different. Steps are kind of similar, but there's an extra step that you don't do with the series that you have to do with the parallel. Okay, that's your homework problem that you're going to do tonight. So let's go on to the parallel circuit. All right, so how do you know when something is in parallel? Something is wired in parallel when your wire splits into separate branches. That's how you know it's parallel. So you're following your wire and all of a sudden there's a fork in the road and you can either go this way or you can go that way. If you see that, that means you have a parallel circuit. All right? In the parallel circuit, the current varies in each of the branches because it depends on the resistance in the branch. So the only way you're going to get the same current, in other words, that the current will split evenly, is if your two resistors are identical. Okay? Otherwise, it depends on the resistance, so your current will be different. And current follows the path of least resistance. So the smaller your resistance, the more current you're going to get in that branch. Okay? The voltage on each branch in parallel is the same. Okay? If one device is removed in a parallel circuit, the circuit remains operating because the current will reroute itself and go through the branch that is still closing the loop. So in other words, one branch opened up, the other branch is a pathway. So it doesn't shut off the circuit. That's why more expensive Christmas tree lights are wired in parallel, because that way if one bulb blows out, the Christmas tree lights don't all go out. The cheapy ones that cost like $1 for 100 bulbs or $1 for 50 bulbs, those are wired in series. One bulb goes out, the whole thing goes out. And unless you want to sit there and look and find that bulb that blew out, it's better just throw the strand away and start over. Okay? Kind of wasteful, but better. All right, so looking at this circuit, the new circuit, okay, the new example, it says that ES equals 60 volts. And the reason they're calling it E is because another word for voltage is electromotive force. Okay? Electromotive force is the same thing as voltage, because it's the pump that makes electrons flow. So they sometimes call it a force. It's just another name for it. All right, so here's my battery, 60 volts. And then I have a resistor here that's 20 ohms, and I have a resistor here that's 30 ohms. Now, how can I tell it's wired in parallel? If I follow the longer terminal, which is the positive, and I go around the wire, I get to a fork in the road. Some of my current can go in this branch, and some of it can go in this branch. Okay? Now, without even calculating anything, I can tell you that more current will go in this branch than this branch. And how do I know that? Because this is only 20 ohms and this is 30 ohms. So less resistance, you're going to get more current. The path of least resistance. All right? Okay, so my first step, again, a step-by-step method will make it easier, because whatever you find in step 1, you're going to use in step 2. All right, so for the first step, I'm going to find the total or equivalent resistance. Same as my first step for series. But how you find it for a parallel is different. It's the sum of the reciprocals, and then you have to take the reciprocal of it. So you're going to have 1 over R1 plus 1 over R2 plus however many things you had in parallel. And you have to take the reciprocal of it. Okay? So the more resistors you add in parallel, the smaller your resistance gets. While in series, the more resistors you add, the bigger your resistance gets. Okay? All right, so I add 1/20 plus 1/30. Okay? And that gives me that 1 over RT is, let's see what it is, 1 divided by 20 plus 1 divided by 30, 0.083 repeating, okay? I have to take the reciprocal of that. So I take the x to the negative 1 to flip it, and I get 12. And so my RT is 12 ohms. My total resistance is 12 ohms. And you can see that 12 is smaller than 20 and 30. So whatever you add to parallel, it's going to get, your resistance is going to get smaller and smaller. Okay? All right. Now, I'm going to do my second step, same as with series. I'm going to use Ohm's law and find the current. So Ohm's law, remember, is VI times RT, the equivalent resistance. So my V is 60. Current is what I'm looking for. My resistance is 12. I'm going to divide 12 into 60, and I get a current of 5 amps. Okay? So a lot higher than for my series circuit. And the reason for that is because I have a smaller resistance. Okay, a smaller resistance, and I think I have a bigger battery too. Yeah, and a bigger battery. All right. So 5 amps of current. My next step is to find the voltage on each branch of the parallel. Now you can normally do that by taking V equals IR and taking the current that's going through the circuit and multiplying it times the resistance for the parallel, which was 12. Okay? Now you realize that because this is the only thing in this circuit is that one parallel, I'm just going to take 5 and multiply it back by 12. So I'm going to get 60 again. So my voltage on the parallel is the 60 volts from the battery. And the reason is because it's the only thing in the circuit. Okay? The parallel is the only thing in the circuit. All right, so now I've got that. And my last step, and this is the extra step that you only have in, whoops, I wrote on the cover sheet. This is the step that you only have in parallels. You don't have this step in series. And that's to find the current in each branch of the parallel because that varies in a parallel. So how you do that is you take the current in the branch is going to equal the voltage on the parallel divided by the resistance in the branch. Okay, voltage on the parallel divided by resistance in the branch. So for my first one, okay, I'm going to take the voltage on the parallel, which in step 3 we said was 60 volts. So we're going to say 60. And I'm going to divide it by the first resistor, which was 20. 60 divided by 20 is 3 amps. Okay? So 3 amps of current go into the 20 ohm resistor branch. And now I'm going to do the same thing for the second resistor. Voltage is the same on a parallel, so it's 60 on each branch, but the resistance is 30 now. So 2 amps. Okay? And again, here's where we can do a check. This has to add up to the total current. And again, because of conservation and Kirchhoff's rules. So that's a way to check yourself. If it's not adding up, you did something wrong, okay? All right, now I asked you an extra question for this circuit also. I said, how much power is dissipated by the 30 ohm resistor? So I want to know the power for the 30 ohm resistor only. I'm not asking for the entire circuit. The entire circuit, you just do V times I, and that's it. I'm asking for the 30 ohm resistor. So I can do one of two things. Since this is the current on the 30 ohm resistor, I could say I squared R and do 2 squared times 30. That's one way to do it. Or I could say, well, the voltage is 60 and my resistance is 30, so I can also do V squared over R. So whatever you like, doesn't matter. My V is 60 squared divided by 30 ohms. 60 squared divided by 30 is 120 watts. So the power is 120 watts. Okay? But again, you could have used the I squared R and just used the 2 amps, not the 5 amps that the total circuit has. Okay? So your homework tonight is going to be to work 2 problems that are identical format to these. We're going to go through and do the steps for the series and the parallel. And then there's also a worksheet with word problems, but dealing with series and parallel circuits. I'm going to give you till Wednesday at noon to turn this in. Wednesday at noon. Okay, so you have all day Monday, all day Tuesday, and it's due noon on Wednesday. Okay, because there's quite a few problems. And then we will have a Zoom class on Wednesday at noon to go over the problems. It's not mandatory. Come if you have questions or if you're confused on how to do these and you need some individual attention. Okay? So that will be Wednesday at noon. And I'll post it on the Edsby site also. Okay? All right. So if you don't, give it a try, see how it goes, and I will see you on Wednesday. But make sure to turn it in because this will be worth quite a few points, probably about 40 points. Okay? All right. Bye.